Hello everybody, welcome to another stream. How are we all doing? Welcome. So last stream we added support for bloom. And my camera's looking a bit messy there on that lens. Maybe it's okay. It looks alright. Okay, it's cool. So we added support for bloom, which is pretty cool. So now we got, bright surfaces kind of look nice and bright. The brightness kind of blurs kind of the wrong word, but it sort of spreads out into the neighboring area. So if we simply just pop open the settings panel, we can turn on, what did I do wrong here? Alright, bloom's on. We turn up the light intensity, this is 1. You see how sort of like the area around it gets brighter. Now we're also seeing a bit of some pixels here. There's still some more parameters we need to tune, like this sort of filter radius and such, depending on the resolution. But, so if you turn it up too much, it starts seeing some of the pixels. So there's still stuff to tweak around with, but it's pretty good. Also the bloom strength as well, how much strength do you want? And stuff like that. So bloom off, bloom on, off, on. Yeah, that's just... So I guess we can try and turn on like the emissive color here. Oh, I ain't got it. It was showing up better last time. Maybe I've just changed one of the settings a bit too much. Yeah, we've seen it sort of spread out a bit. Where's the filter radius? I don't know. That doesn't do anything at the moment. But anyway. So bloom is now done. So this can help us sort of view emissive stuff better, basically. So we'll see sort of kind of a little bit of brightness around the edges of things and such. I don't know why I'm not seeing it here though. It was kind of there earlier. Kind of there in the previous time, but there we go. Maybe it's... I don't know. But cool. So today what we're going to be doing is starting on the material editor design. So this is the old material editor. It was just exposing like a basic material property. We didn't have any albedo set. Right, that's why. Okay, there you go, really seeing it bloom now, look at that. Oh, lovely. So this just exposes albedo, emissive, and emissive strength, metalness, and roughness. These are the only properties that we have right now in the renderer. And we're probably just going to stick with ones like these, to be honest, for a good while. I don't know, we'll see. And I initially thought let's just get a very simple material editor in here, just change the properties. But then the issue is like we might want to sort of like texture these ellipsoids. Basically, they're not spheres, right? They're ellipsoids. So I want to have a way to do that, but in the chat on the Discord, I've been speaking with Russ Musco like a month or 2 ago about it, and he uses procedural materials. So he basically like programs in shaders a material, like the texture and everything, like with procedural noise and stuff like this, and that'll produce like a texture for like albedo, emissiveness, another one for metallic, another one for roughness. So you can imagine having, hey Captain Cheeky, how's it going? So in like Shader Toy, for instance, if you just have a quick look on there, they've got some for like procedural wood that's been made. So just completely with code. That's a very basic one, but There's another one. So it's just all made with procedural code, basically. So I'm thinking, and this is not anything new. If you take a look at like, there's tools that people use in the industry called like Substance Designer or whatever. It's a full-on like node graph system where people are basically doing programming and they make materials. So that's all they're doing, right? So I'm thinking, why don't we sort of like, I don't want to do a runtime like Russ Musco was doing, where his little bit of shader code was running per pixel. I want to sort of pre-compute this and output texture files, a bit like what Substance Designer does, but I don't want to do the whole node graph thing. I just want to make something kind of basic that will expose essentially a few properties, which will allow us, so expose some properties like these. Oh, my days, amazing campaign, thank you. Appreciate you, sir. So to rewrite my game, fair play. What's caused the what's made you think about rewriting it? Did you just get to a dead end, or did you say get past the prototyping stage now and you're gotta, you know what the game is you're trying to make, so you're just gonna, do it properly this time? Yeah, thank you, Campaign. Appreciate you, sir. How are you doing? How's the weekend going? So I'm essentially thinking allowing basically a bunch of custom properties to be specified. And those could be colors, they could be floating point things, right, or integers. And those get fed into a custom shader, and that custom shader generates a custom texture. And it's just all controllable through some dials and things, and hot reloadable code and everything. So that's what I want the new material editor to be. We're going to go into more details about that and fully design the whole thing today. Hopefully I've already got started on it in here. I've got a whole document. So yeah, I guess we can start going over this briefly, and then we'll probably start by doing this restructuring of the project, because that won't take too long, and then it means we've achieved something today, like code-wise in a sense. And then we'll actually talk about the whole sort of material system that I've been thinking about and get it all written out, all the tasks written out at least, just so there's less random surprises and we can try and sort of gauge how long said thing will take to build. And if there's anything we can be like, that's too much to do right now, let's do this. Those sorts of things. So the basic idea, that's a bit of bloomage. Yeah, it's like bling, 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 boom. Bloomage. Hey Pete, how's it going? Yeah, it's quite pink. I like the control C and C++. Oh, interesting. Oh, wait, did you write it in like JavaScript or something? The first one? So you rewrite it in a different programming language. That's cool. Mad respect. Doing good. And the week is fine. You're trapped in the market because I'm a dummy. Now, with all the tariffs coming out, when I was doing much money. Oh, right, okay, right. So you saw like maybe there was an opportunity with like the election and Trump getting elected. So he was like, let's put some. I see. Yeah, I was not gonna lie, I was tempted a little bit by that, but I never did it. I was gonna be a dummy too. But that's cool. You win some, you lose some. That's the whole point. But yeah, I don't know. Like, Trump's obviously gonna rock the boat. Put it that way. But that's just when you do a bunch of change, it's gonna happen, right? So it could go positively on. It could go really well or really bad, or it could go really bad initially, then all of a sudden go really well. Like no one knows. Like, or it could go really good initially and then really bad. So you just gotta, yeah, it's the whole point of those sort of things, isn't it? It's risky. Go dot multiplied by C++++. Okay. I vaguely understand. But that's cool. I'm glad you're, getting down to more of the low level side of things, getting all that control in there. Oh, day trading. No. Right. No. Man, that sucks. Yeah. Well, I hope you get some luck in the future on those bets. But yeah, I was considering at least putting some monies in at some point. But yeah, because we expect to be recovering from COVID soon. You know what I mean? Yes. But did I not tell you what I do for my day job? No. Oh no, I think you did actually. There's so many people that I interact with, Captain Chica. I cannot remember, but you actually do embedded work, isn't it? From memory. Now that you've reminded me that you've told me, is that right? I I hear from so many people that it's just sometimes it's a bit of a nice a nice blur, a nice smudge of people in my memory. Yeah, there we go. So sometimes I do forget these things, but that's cool, interesting. Right, I see now. Right. So you was just using Godot and using GD script. Is that right? Okay. Yeah. Yeah. Embedded, around where I live is zero embedded stuff. And then when you go to London, it's like there's people doing embedded who do Python development. It's like you do your thing. I'm gonna go elsewhere. uh, yeah. Weird. The UK is produces software engineers from schools. Like you barely even know what goes on in a computer when you pass and get a degree. This is just how it's going. Yeah. Yes. Scary. So PBR. So basically, we just want to procedurally generate. The goal is right. What is the goal from said material editor? Oh, that's some material on it. Goals. Right. So the goal is to procedurally create textures inside the engine. Right. And goals and stuff. Oh, okay, I already put it there, and right. So there's one. Okay. We also want to allow for reuse, right? So we want to, create sort of like a prototype material with a bunch of properties, exposed properties. Let's see if I can English today. With exposed properties to essentially create many sort of material, many other material, many similar materials, right? So you can imagine this is like a set of different shaders that run, but there's configurable parameters, and then that's outputs your albedo, your emissive, emissive strength, mildness, roughness, and height textures. So and the other goal is it so for obviously to be, it's got to be easy to use, right? It's got to make it. That's why the whole reason why it's integrated in the project, so we don't have to sort of like build it in this other tool and then switch over to this different tool. It's all sort of should be integrated in with the engine, and we should be able to view sort of like the ellipsoids and things that they're going to be on, stretch them and stuff like that, and see how they look on the actual ellipsoid, right? Now these are procedure generated. They're going to be cached into textures, and we're not going to procedure generate them at runtime. It's just all at build time, basically. So there's a bunch of textures that get made. So I think we'll probably have like, these are the sort of ones that you could possibly output, I guess. And then right, so I guess you should be able to output whatever you want, but you can usually generate them out. Okay, so these are the one. Yes, this is how they're going to look actually packed inside of the texture file. We'll probably pack them together like this. But then when you generate them, we'll probably have them as separate textures or something. So the material is going to have albedo, which is just going to be sRGB. We're not going to have a HDR workflow, I don't think. Yeah, I don't think we're going to have a HDR workflow. Well, the HDR bit is going to come from an emissive base color, which will be an sRGB, and then multiplied by some emissive strength. Now to some roughness. We can put those as separate textures here. And then we'll have a sort of a height map as well, which is probably just going to be used to help generate the normal map and the normal map and the AO, and maybe some other sort of like shadow stuff as well, shadow maps as well, we'll see. So ambient occlusion basically. Now, my company fired MicroPython teams. Oh wow, they actually exist. They want too much for their non-portability lower than controller itself. Wait, they want too much for their non-portability lower than controller itself. Huh. Interesting. So they're writing. Can you phrase it again, Captain Chica? So you're saying they're writing more. The code's not portable, and they're wanting too much money. Is that what you're saying? Right, someone has to do the hard work for them, basically. Right, I see. So all they want to do is do the glue code, right? And just forget that there's a machine under there. Okay. Super G, wait, is there a series for the C compiler? I did stream it live, but I don't think I put it up anywhere. So it's not recorded, I don't think, no. I did spend about a year on it on stream though. But yeah. That's about it. So the material asset, but yeah, this game without an engine or engine without a game does have a VOD channel. So there's past VODs on there, and if people do subscribe to there, we can start streaming on YouTube as well very soon. Couple more 100 subscriptions. They're free, obviously. You subscribe for free, and then we can get streaming out to more people, which would be probably cool. So I appreciate everyone who does follow over there. So we're gonna have a material asset file. It's just gonna be a tar file. It's gonna have these are the sort of packed textures. And later on we'll probably block compress them so they will take less space in RAM, and they will, sorry, in VRAM, right, on the GPU, and then also they should probably, I think they sample quicker as well because there's less, you're taking up less of the bandwidth basically by sampling block compressed textures. Because they block compress a 4x4 tile into 8 or 16 bytes. But you do obviously get some, they're not as good quality, but they'll be a lot faster. I said a lot. I've measured it, they'll just be faster, right? In some metric, maybe 20%. I don't know yet. But yeah, that's going to be a lot more fiddly to get that to work. I've seen open source block compressed stuff I could chuck in, but I'm looking at some of the newer block compressed technologies like BC6 and BC7, and they're a lot more complicated, and I was thinking I might want to use some of them because they offer better quality, but yeah, there's BC1 compressors and stuff, and there's tools to do it. I was just wondering, I don't really want to do that pipeline just yet. It's an optimization we can do later. That's the basic idea. Are you currently using the compiler? Could you show the advantage you got from making it? I'm working on a compiler right now, doing some type checking, getting my mouse cooler right now. Yeah, well, I use it right now. I've literally just got one graphics shaders file.c, and I've got about 5,600 lines, and this is it, right? It's just a C compiler for shaders. Now, it's obviously a subset of C. There are restrictions. They are on the GitHub. Yeah, they're on the GitHub page, right? The limitations and that. But yeah, the best thing about it is I can share these sort of structures. So these are the push constants which go from CPU to GPU. They're like a small, like 64 bytes of memory that get with every dispatch of a shader. You can just pass them up. And I can pass in resources. My resources are using binderless, so I can pass up indices basically. These are just indices, that's what they map to. And then I can share this between CPU and GPU. I don't have to redefine these things. All the buffers with arrays of things, they're just structures I declare. And again, the share between CPU and GPU, I've got a bunch of maps code and a bunch of like collision checking code and ray verse whatever code, intersection code, all share between CPU and GPU. And yeah, it's really handy. I've also got the ability to print from GPU, and it prints back out on the CPU side out into a terminal, and all built into the sort of a compiler. Yeah, it's really handy, been very powerful, and yeah, I would wish that we get to sort of program in something like this. Everyone else does. It would be great if our tools, why did it take so long for us to just have the same sort of languages that we have on the CPU just to be there on the GPU? I think some people have the argument of like, we need domain specific languages because swizzling, but just put the swizzling in the systems programming language, right? I think Odin does it with the arrays and stuff, which is a really good way to do it. And so if the language has to be a bit neutered, right? Why can't we just have a language which is shared between CPU and GPU? It'd just be nice, But yeah, that's about it. And I compile all of my code into a single SPIR-V file. If I ls my build directory, I've just got a single SPIR-V file. It's got all my shaders in there. And that's it. It just takes, I know I build my whole game at the moment in a couple of seconds, which includes less than a second for, well, it's less than 2 seconds, right? But it's less than a second to build shaders and less than a second to build my executable at the moment. So yeah, amazing. So that's how it is at the moment. What sort of compiler are you building for? What is it, like a little custom language? So yeah, we're going to obviously pack our textures into this sort of format here. Later on, there will be block compressed. Yeah, we won't need the AO map yet, but that's just an idea. Maybe we'll get rid of AO. We won't actually need it for now. Okay. So the basic idea is for the whole of February, we've got about 12 streams, including this one. No, we have 12 streams, including this one. So I'm thinking about why don't we get started off by restructuring the project a bit? Because we're going to be building a new tool called the Material Builder. And it's kind of going to be like, it kind of needs to be like another executable but it kind of needs to be a library as well. Or I don't really have libraries. I just include everything into another executable, but it needs to share code between the editor because the editor needs to kind of use this material builder in a sense or parts of it, and it needs to be an actual executable. So when we sort of build the assets, it will build these procedural materials into these PBR textures, right? So if we take a look at right now, we already have a couple of programs. They're here: encoder generator and entity generator. These are code generators. So I need to move these around as well, rename them a bit to like code generators, but they're separate tools. And right now we've got this sort of like source directory where all of our code goes. And I was thinking, we've got this engine folder where I moved all the sort of core stuff into this engine folder. But it really gets difficult to know, what goes into the engine and what goes into the game. So I was thinking just pulling down this folder, putting it all out into a single folder and calling it code. I did have it that way before, but now I'm just thinking it makes more sense because I've got this thing called settings. It's like, does that go in the engine or does it go in the game? Right. Just, it's called game without an engine. Why have we got an engine folder? Let's just bring it all out. Having a line where we decide where, is kind of pointless. So I wanted to make that change as well. And I was also thinking about making probably a modules folder where all the sort of libraries go. They're not libraries because we don't really compile them out into libraries at the moment. They're just included in. And we'll have like an apps folder as well. So we'll change the source to code because I was thinking that we're going to be building a bunch of assets. So these are kind of source assets, this assets folder. So like, why have I got this thing called source here? It should just be called code, all right? So just got a bunch of these sorts of little changes that I want to get done first today. We'll have like a couple of build scripts for building the tools as executables, and those will be checked in. So like the code generators and the build tools, like for building the material assets and stuff. And we probably also want to, yeah, that's it. So that's all we want to do for the restructure of the project. The built assets will go in the build directory. This is all not checked in at all. And there'll be another asset directory in here, so we just got to get all that set up. So I want to get that set up today, and then we'll go over sort of like basically planning out the rest of this material this material editor and how long it'll take. I think it's going to take more than February because it is quite involved, but yeah, maybe 2 months at most. That's what I'm thinking. So I want to try and plan it all out so we know exactly what we're doing and try and avoid all those sort of like random things popping up and being like, oh crap, this is much bigger than I expected it to be. Just try and find all those things up front and see if we can maybe save some time by doing a more simpler thing, or designing it in a slightly different way or something like that, right? That's the idea. So we'll go over that soon. We'll just get started off with the restructure. Quick question: any good C login library? Or I need to. So, Mr. RXI made a very simple logging thing. Logging is like very simple. So it just does something like this. I use this one as inspiration. Two seconds, this is getting cold. So RXI, he has a very good mind at just doing the simplest thing. Like, it's a very hard thing to do, but he just manages to do it. So that's the header file. It's literally like 50 lines of code, and it is obviously basic, but this is what you want. Sometimes it's a good place to start, and it just will go over. Then the implementation is 150 lines. So I recommend doing your own, but just take RxI's as inspiration and make it, and do one for your needs. We're going to be using one of RxI's libraries, though. We're probably going to make one improvement too, because I think it doesn't allow you to output into memory. But there's RxI's made microtar. So it's just an implementation of tar, the archiving format, right? And again, it is how many lines of code? Well, less than 100 lines of code, 100 lines of code for the header file, and then the implementation is less than 400 lines of code, which goes to show you how simple stuff was back in, like, I don't know, when was this designed? In like the 80s or something, the tar file format. When was tar invented? Tar release, initial release date. No. Oh, come on. Okay, so basically the 80s. Wanting to show you how simple stuff was back then. And two, it just goes to show that RxI does not overcomplicate things, right? So, and we're going to be using this to package our materials. So our .mat file, it's just literally going to be a tar archive with a bunch of texture files in there. They're going to be uncompressed, but later on they'll be block compressed. They'll just be uncompressed pixel data. I was thinking of LZ4 compressing it. I did test it. LZ4 compress actually does all right. Here's my downloads. Here's a bitmap I took, 15 megabytes. I think this was a 4K image. I forget. So I took this image. That transparency. Oh yeah. So I then LZ4 compressed it. It took it down to 8 megabytes, and then I Z compressed it and it took it down to 7.4 megabytes. So I was thinking maybe doing that, but I think I don't really need it right now. But later on we will block compress. I wish there was more appetite for educational content like this in Handmade Hero. I'm making my own language of superset of C. Awesome. Mostly just C with generics and some dynamic arrays built in. Nice. That's cool. Yeah. Yeah, that's good. That's good. Yeah, because most people like complain that, oh, there's another operator overloading, but most of the time they're complaining is because they don't have vectors or matrices, right? So I think that, yeah, that makes a ton of sense. That's cool. Approved. Oh crap, I didn't pour on my Coke. Luckily I still got the ice. So, restructuring the project. Here we go. So we get to use a bit of Git, which is incredibly dangerous. But it's okay, because I've checked everything in and I've got it all backed up on another computer somewhere else. Oh yeah. So, what we're going to do is we're going to git move the source directory first to the code directory. Simple. Well, there we go. There's a ton of stuff all moved. Here we go. So, what is next? All right, let's get this directory up. So the next thing I wanted to do, so yeah, we've changed it to code because it was called source, and these assets are kind of source assets, so why not call the code, that sort of thing. The next thing is what I kind of want to do is make an an apps directory and a modules directory where all of the modules will live. So the applications can just go and look at any of the modules and just include those, right? And obviously the modules will include on other modules and stuff like that. So we've just got to be careful of all the sort of spaghetti includes going on. But besides that, it should make an improved way of doing things, because right now I just got a scripts directory where I got my encoder code generator and my entity code generator. They're going to be applications or tools, apps, where they will get compiled out into their own things, and they can reach into some of the shared code, the modules, right, and reuse some of the code there, which would be cool. So let's get started by just sort of making a modules folder, and we're going to take a cd into the code. I'm already writing source. There we go. And we're going to git move engine star, right? Everything in the engine. Goodbye engine folder, right? Into, oh crap, I didn't not git. Make directory. We're going to make a modules and an apps folder. Now we do the git move engine star. We're going to move that into modules. And then the next thing we would like to do is move. Now, with git move, can you do like a bunch of sources into one destination? Yeah, there's like a dot destination directory, right? So by this documentation, I'm not going to read the rest. It says set thing is supported, so fingers crossed, eh? So I want to move the editor. I want to move graphics. I want to move, let's move the graphics.old as well. That's the old one that we kind of look into sometimes. There's one called logic, which is kind of like the game logic, but I want to remove that. Setting. Yep, and then we're moving all of that into modules. Well, I said fatal. It might have been that .old directory. Right, that graphics.old I don't think is checked in. That's why. So I have to move that by hand. Cool, so this is looking better already. So, right, what is next? So in terms of the applications, there's a main folder here, right? So we want to make a game. I have got a list of things. So we've done this one now. Let's check that one off. Check. Move the source to code, right? Move code engine and code that into there. Yes, so we can delete that engine folder now. So this is again a game without an engine. Goodbye. Good to be back. So move code/main to apps game main. Okay. So this is step one. We are using an unsafe language here, Captain Chica, so we must live and breathe the unsafe methodology. We keep going and we don't commit until we've done the whole game. No. Well, we'll commit. We'll commit very soon. After the whole file restructure is done, we'll commit. So we're going to make a game. What other ones we want to do? We want to create a kind of like a encoder code gen. encoder code gen. So that's just that lovely encoder system we've got. We've also got the entity code generation as well. That'll kind of be nice to have its own little one as well. And we will obviously have the material builder, which is what we are planning to make. So it takes in a material file and outputs, well, it takes in a material asset, which is basically just a bunch of descriptions and what shader to run. And then it will output a lovely set of images all packed into a tar file and something that the game can load. So that'd be awesome. So there's all the applications that we've got so far. And what we've got to go ahead and do is git move that main in there. So we're going to git move main.c into apps game / main. Well, on that right. Oh yeah. And this sort of game.h and game.c, this is what I would say is that logic thing. So what I end up doing is having in the game, so it's going to modules. I had a thing called logic, so it's like game logic, right? You know, and if you're doing a business app, it's called business logic and all this stuff, right? So let's just call this folder game. So it's the game module. So it's everything to do with like the logic of the game. And so it's going to have like the entities in there, the levels and everything. I've for some reason got the material in here. Well, this is the old one. We'll clean this all up. And a bunch of testing stuff. Because we don't have a game yet. But I have a sort of game. Yeah. So these game files where it's like, where it actually kind of spawns the entities and has a bunch of debug drawing stuff and stuff like that, right? So these are we're going to change that logic. We're going to git move that logic directory to a game directory. Yeah. And then we're going to git move the game.star to modules game, like so. Beautiful. So I think we've done all the shuffling. Right now it's time for a bit of massaging, I think. So we're going to massage all the code to adjust for this huge sort of shuffle of things and get it all building again. Although did we... there's going to be some other things as well. All right, let's tick some of these off. So create the folder at least. Rename logic to game, put the game in there. Yep. Move scripts. I didn't actually move the scripts yet. Let's do that. Oh, there's a whole lot of stuff to get working there. This is the way. So git move scripts. So encoder gen .c. It's a lovely C file that we've been building. That one goes to code / apps / encoder gen. So if we want to make it sort of like a more general, that's one way of saying it. If we want to have multiple kind of code generators that sort of work off of this encoder system, we'll move it out into a module. But until then, it's just a whole application. I don't think we'll ever do that, but it's a possibility. So then this will be named maybe main.c. And then we're going to do a git move on scripts entity gen .c code apps entity code gen main.c. Okay, nice. All right, anything else to check off? Create tools, Windows, Linux for the precompiled tools. Yeah, so I think I'm going to check in any of the tools precompiled because there's no point asking people to sort of like, hey, make sure you build those tools when you sort of set up the... Nah, maybe... Nah, maybe we'll say you gotta run the build tools, then I gotta write a readme. Alright, but I'm ready for this. I'm ready. Okay. Oh yeah, then we need the graphics material builder under the modules as well. So that'll be a mkdir code modules graphics material builder. So that's where all the shared code for that material builder is going to go because it gets used in the editor as well as the material builder executable. Nice. So let's get the game all up and running. Let's do a nice bit of massaging. So first of all of the modules. So we've got to probably do a nice little search for engine slash, let me spell engine right first. And we've probably got to replace all of engine slash with module slash. Or we could, or we could get rid of all of module. Alright, here's what we're going to do. If we get rid of all of engine slash and then just make sure that the sort of include directory is in the modules folder, jobs are good. It's just like an include folder, right? So that'll work. So engine slash goodbye to you. Oh, for crying aloud. Alright, one file and the next one. So I guess while I'm doing all this massage, and if anyone's got any questions about the project or just questions about my thoughts on things, feel free to ask away and I'll happily multitask. Right, the next one is for engine again. Oh, backspace engine. No. Oh, crap. Nice, it's going well. And yeah, it's always a weird thing. It's like, what goes in the engine, what goes in the game? It seems pretty clear for some things, but other things it's like, this could do better in the game. So, why are we putting this artificial limit, like restriction, when we've specifically made the project name game without engine? This is going to be much better. This is the way. Then we've got to change our build script to sort of point to the modules folder instead of the source directory. Find type. Yeah, but that's scary, Cranston. Yeah, I do not know said. Thank you for trying to help me with the speed up, but it's cool. Oh crap, this is the code generated stuff. Let's do it anyway. We'll rerun the code generator. It's not that big, I think. Well, maybe. 92 times. But most, yeah, it's not 92 files though. Random question. I'm the only one who still writes pure C libraries like 1984, one symbol, one file. Or did people used to do that back in the day? When you have all these sort of compile module, like compile modules, compilation units. I can take every opportunity to solve my overpowered tools. It's yeah. See, that's my problem. It's like, well, I've never learned them. It's because I've bitten myself in the butt doing it in the past. And damn it, my laptop, man. Got an older Wi-Fi card, and my new router is just like no sometimes. So now my laptop won't even bloody connect. Ugh. Technology. Computers, eh? So I guess every now and then I'm just going to check back here. Hello, Lupa. How's it going? Hey, Perry. How you doing, sir? Welcome. How are you? I mean, every standard C library is written pretty much this way for whatever reason. Yeah, I've looked into some of the source code at that. Like, they don't do it for every function though, but some of them do. I can't deal with files. Like, I've actually got quite a lot of, I would deem as quite a lot of files in this project because I have like code generators and stuff. But I'm thinking about ways of how I can reduce this further. And I've got sort of these shared files, like this graphics shared here, which basically like means, hey, it's shared between CPU and GPU. And I'm thinking of ways where I can sort of like not do that. And I've got like an internal header file, which is another thing I do in this project, where I say like, hey, this is all the full declarations for all the internal stuff. So you know, you can have a nice zoomed out look at the whole file basically, you know, what's declared in this, and I keep it all in order and everything and all of that, right? Because it's just me on the project, I can do that. But it adds many more files than I would like. So I'm thinking of ways where I could like, thinking of ways where I can reduce that. Because I just like having less files. I cannot stand it when you got to try and find something in a project and you've got to look through tons of files because you don't know where it is actually declared, and you've tried searching all these things and can't just quite find it. HCC command line, write that in it. Change that one. Isn't it to force C compiler not to strip functions that are usually hidden behind macros? Huh. I don't know how sticking in another file will do that. Developers, yes, that's good. Good old Borma. The compiler knows enough, I guess that. Yeah, maybe it's incremental build stuff, yeah. Probably. February, yes. Yeah, February's usually like the coldest month. Like December's usually like pretty chill. but then February is like, usually it's going to get you. Sometimes it can be quite warm in December as well, when you expect it to be Christmas time. Right, we're nearly there, I can see it. This is the type of thing where if my boss, okay, going back to if I was like 17, and my boss is like, hey Henry, I want you to do this task for me, and it's literally just removing the engine. Or, you know, just moving all the files in a directory and getting rid of the engine slash. I would have written some script or used sed or whatever it is, right? And done it that way. And just been like, look, I've done it now and done it in like seconds. But since I'm now older and I've bit myself in the butt with these tools many times, I am doing it this way. And I'm just sort of taking a look at all these damn files I have, and how this would have been easier if I had less files. Less files is the way. Two files per module. That's what I need to get down to. Some of them have that, but most of them don't. And we're done. Right. We did it. So the next thing to do is try and get it compiling. I just remember the reason. It's the standard editor. Oh, why is that? Why would Ed... Is Ed really good at having stuff in a bunch of files? Like, I thought old school editors would make it hard to work with multiple files. All right. I guess I'm going to pack my laptop away. It's going to be no... Oh! Wait, just reconnected Wi-Fi. This never happened. Oh, wait, just disconnected again. When I open up the web browser, damn laptop. Alright, I'm closing it down. Okay. You don't have to use files larger than 50 lines. Why is that? Well, so you're... That just sounds like a bug that no one fixed. Okay, so the next thing to do is to go to the main folder. Sorry, file. Which obviously has the main function in it. And some other things. This is obviously for the game. So this is where it's all moved now. So... Oh yeah. So there's a thing called compiler flags. So this is all of them. It's a new line separated thing. This is just what Clang likes. It's a wonderful design. And so now we have so the include directory, what I want to move it to is, so it's code/modules. So now, right, every time we do those sort of angle brackets, or it does those speech brackets, and then that fails, but angle brackets it's what you typically do. It's going to have access to all of these. Nice and easy. There's no engine folder anymore. No silly little line in the sand for some reason between the engine and the game. So each module will obviously have its own dependencies to other modules. We've got to try and keep that good. But, you know, it's just all in this directory now, and we've got a separate apps folder where we've got the game, got this new graphics material builder that we're going to be making over the next couple of weeks, maybe the next month, something like that. Well, no, next week or two for the actual material builder, and then we're going to be going into the editor and things and doing that. And like the code generators here for the encoder system and the entity code gen, and more things will appear as time goes on to help build assets and things. So in the build.sh, there is also, we're going to look at this. So here's the HCC compiler that we use for compiling our shaders. Now, there's no source anymore. So that's code, because yes, we have source assets, so where do we not have source assets folder? It's just called an assets folder, so it's called code. Code, build.bat. Alright, it's just the Windows side of things. Anything called engine in here, or any -i for the we did -i code, right? Code modules, yeah. Cool. So it's looking all right. Oh wait. Yes. So HTC does it as well. Gotcha. Nice. Okay, so let's do it / for source anywhere. Where's my music gone as well? Go and write code in Ed? No. Why would I do that? Yeah, it's crazy when Richie died and no one really knew. It wasn't really that big of a statement, you know, when he died. But he basically helped make Unix. He helped make C as well. Obviously, he's a primary person behind C programming language. And when Steve Jobs died, like a year later, I think it was. I forget the exact time, so a very, very short time. Everyone's like, "Oh, Steve Jobs died. So sad, big death. He brought us so much in technology." And it's like, a year ago, the person who made C died and Unix, and like it was nowhere near as big as that. But yeah, strange. It's a bit like in films. Like everyone knows about the actors and stuff, and the actors are like really important. But the amount of people that make films and put work into films is all like, I think the second most important is the director, right? Director's really famous, but there's all the people who write. There's so many people who do everything for the film. There's like costumes and people do like lighting and basically like making games these days, isn't it? All the sort of editing and everything, and even programming the sort of render engines they have. Yeah, actors get all the spotlight for some reason. It's just weird. PDP 11. Right, that old machine that I have no idea what it is. Because it was a millionaire, guess so. Linux kernel in 30 seconds. Pretty quick, I guess. Considering how big it is. Mr. Dennis Ritchie would have really been well known for highly technical people programmers. Most consumers have no idea what C is. Yeah, true. But he did get some award by the president, Dennis Ritchie. There's a video on it. That's how I know. From like one of the presidents, didn't he? He got it from there's a video of it on YouTube, I think. He gets some like medal or something for the Unix operating system, and no one knew what they were talking about. It's a while since I've seen it. Right, I don't think we mentioned the source directory anywhere. Ooh, we kind of do. Source, logic, entity layout. Right. We've got to do some massaging here. Ooh. Right, there's going to be some breakage. So, code, modules, game. Right, definitely hard coded. Oh crap, what's this in here? Build a bat? Oh. Oh, right. So when we build the encoder gen, that's got to change to be different. Right, so encoder gen. Source logic. So code game. That's what we renamed it to, wasn't it? So code editor, code graphics, code settings. This is just the encoder files that we have right now. It's got to be passed in from some build system at some point. Right, there's a couple of source things in here. What's that about? Dot source. Why would you dot source? Why would you not just... As I say, we stand on such shoulders of giants. There are many people who contributed to the progress of tech science. We don't know about them. I guess so. Our concern is the fact that regular people don't appreciate the foundations atop of all their beloved technologies work, at least if we're more technical literate, we can do our part and express that appreciation. I guess so. Yeah. But it goes to show that yeah. Yeah. It's just strange, right? I don't know, we're going through a bit of a time right now where I think like the amount of those like people not really appreciating so much like famous people in like the movie industry and that anymore anyway. I think I'm going through a bit of a time where that's being sort of re-evaluated. So I don't know, you know, maybe foundational people will maybe get appreciated more, or because the world is going to a bit of people going to their niches now these days with all the sort of, you know, when you go and talk to someone about like, hey, here's a person I watched on YouTube. That person you're telling has already got a bunch of people they're watching on YouTube, and you never knew those people who they watch on YouTube. So everyone's kind of going into their own little niches now. So maybe some of these sort of like foundational things will be exposed more because of these such things. I don't know. Pretty amazing times we live in. I never thought it was better than right now, technology-wise. Yeah, I guess so. There's definitely like things we've forgotten though, like different methods and stuff, like through time. But yeah, in terms of like electronics and stuff, it's probably safe to say that we are definitely the furthest along. So I wonder why this code generator, the encoder system, decided to... Right, so at the top of the source file. So right. Oh, it's because I put the path in there and it's relative from there. Okay, so we'll get those regenerated at least. Maybe we can just point it. Something like that. Let's just correct it, but we're going to recode gen anyway. Oh, it's in game now, isn't it? Good. Yeah, I don't know how many of those we're gonna... Code modules game, that's right. Cool. Right, then in entity modules, we want it to be the include directory, okay? Nice. Cool, so there That's all the renames sorted there. So now I'm going to try and get it building again. Let's try and focus on the game first. So if I run the sync it first, let's run the... Well, let's just run the whole thing we used to do, sync. Okay, so code graphics doesn't exist, so FI. Parallel universes, I don't know. Sounds quite unbelievable, to be honest. It sounds like just a scapegoat for explaining a bunch of things. You know. It's just quite convenient that anything and everything could be happening. Like, whenever that happens in a sci-fi story, I'm just so bored. Like, I love sci-fi, but when I hear parallel universes, it's just like, okay, go and watch something else now. So in the build.sh in HCC, we have some include directory. Oh no, we input file is in modules graphic shaders. Okay, good. So I didn't do anything else there. And so let's go over to the bat file where we do the same thing, right? This is on Windows. Code main CS, the next one. Okay, so HCC ran fine by the looks of it. Yeah, so now Clang's running and modules main C. Of course it's not going to be modules main C. So it's in apps game main C, of course. So apps game. Game.h. So in main.c, there's a game.h file and game.c. So these ones are game. Gotta be careful here. Right, so in game.h there's a logic entity. So that's game entity and close, I guess. So in the Vulkan backend thing, we include game for some reason. We don't need that anymore. That's because we used to have some custom allocators, I think. Let's not do that. So it's in the core directory now. We had some sort of global thread local storage allocators defined in the game for a long time ago. It's never removed it. Main C logic entity, right? Getting close. Not used directly, I guess we can get rid of those. Thank you, IntelliSense. And all right, let's rerun that. Right, an editor, of course. There's another one. So game.h, that will be, oh sorry, game.c. game.h, but equally that could also be nice. Wow. Okay, so that's great. So we've done the restructuring now. We've got the old code up and running. We've got to still get the generators adjusted, but we're pretty close. And then we can get, so that's one application. That's our biggest application, obviously, is the game. So we've got the script running to get this game folder, main C file compiling, with this separate modules directory of all the actual code is. So the next thing to sort out is the the encoder system code gen and the entity code gen. Actually get those running and everything. And stuff like that. Okay, so, and then after we've got those running, we can look at we probably want to build some other shell scripts or something like that, just to sort of to actually build the executables separately from actually running them, I think is the idea. And then we would like to, what else would we like to do? Yeah, I think that's pretty close from then actually. And then I guess we can start doing this plan and talking more about the plan of over the next month in detail and figuring out everything. Okay. Very good, very good. Right, so if we go to, there's another file called okay, so in the scripts directory is where I like to put all of those sort of, whenever you want to do anything, I think you should have a script for it. You shouldn't have to remember hey, what's those command line arguments for this thing? But yeah, so that's basically it, right? So we have a sort of encoder gen.sh in that, right? So these should probably just say, what these are basically saying is build the tool and then run it. So I'm thinking, why don't we make a different script, call it build tools, and that builds the encoder generator and the entity generator. So whenever we make changes to that, we do this, and that will put it in the build directory, and then we'll have a build assets as well. So why don't we go ahead and make those. Build assets dot sh, build tools dot sh, and then I guess, say if we want to run say we want to do all the code generation stuff, we might just have another one called code gen for now, but in future we'll have a proper build system, I think. So we'll just add things to this code gen. I think that would be a wise idea. Okay, that's all good. So it'll be a code gen dot bat windows dot bat dot bat. Okay, good. So let's try and migrate some of this over. So in terms of encode gen dot sh, so it's just gonna, all right, and then we're gonna go ahead and move that into build tools. Now just gotta be careful. There is a and then run it. Don't run it in this one. Not doing that anymore. So we're gonna put it into build underscore code gen. So this just builds all the encoder stuff. Scripts. So this is the C file, right? So the C file actually now lives in code apps encoder codegen / main.c. Right. Now we copy that again. And I guess we'll put the and after it. Do a backslash so it does the new line. And entity codegen, entity codegen there. So we'll add more of these tools in and things for when we, like the material builder and stuff like that, right? I've come to the conclusion what one thing I for sure miss in C that C++ has is the ability to put : in front of stuff that I did not write code for. But why? So like, you're saying you missed namespaces then? Because like, or is this stuff declared inside of a function that you can then access stuff more globally? Is that what you mean? Hey, cover lovers, you support atomic floats? Not on GPU, because I don't think they're very well supported. But they are supported on the sort of newer hardware. So there's a trick you can do, where if you want to do an atomic max on a float, you can do it with integers. But you've just got to be careful. So I guess what are you trying to do with atomic floats? If you're just trying to do like a max op or a min op, and your float is is positive, what you can do is you can basically bitcast your float into an int 32. So you take your float value and you get it as some unit, right? Then what you want to, then all you need to do is do your atomic max with whatever the sort of destination place where it goes, right, in the buffer, with that value there. And that would be this, like, as long it's just got to be a positive value. Negative values it wouldn't work. So the bit representation of a float, when you do a comparison on it, it will be the comparison operation will be this, will work out fine as an integer if it just is positive. So that's a little trick you can do to get around not having float support. So build assets. So there's a sort of encoder gen.bat. So we take all this and we move over to build tools.bat, drop it in there. So this is just all my arguments and stuff that I wouldn't use before. And again, encoder codegen.exe. And then the place where it lives is code, apps, encoder, codegen, main.c. And we don't run it afterwards, obviously, right? And to carry on to the next line, you do the hat instead of a backslash. You got to make sure you do a double and, I think. Well, you run it again. This time for entity codegen. Not the namespace and or the static accesses itself, but rather the ability to visually mark something as not my code. And I have to worry about something will break later on down the line, right? Interesting. Mm. Yeah. C could have done it better with the way it does modules and like libraries and stuff, right? They come from like a module or something. Or as Odin puts it, like a package. They could obviously have been better about that. But I think that probably solves your problem. Like, I don't like namespaces because they make it such that I can't find where the function comes from with just a simple string search. So as soon as there's anything namespacey going on, I do start to question whether it's worth it or not. Also, the bitcast is kind of nasty though. Yeah, that's true. Yeah, but the support isn't the best, I don't think. If we go to gpuinfo.org, or the Vulkan side of things, there is I think if you go features 1.0, just 1.0 probably. Right, that's 64, that's not it. So looking for float atomics, they probably come in at 1.2 or 1.3. Should have just searched atomics, really. Oh, are they not even in? Are they extensions? So you got the integer 64s in that, but wow, I don't know if they even are. Okay, there might be an extension, which is even worse, but yeah. So I guess you just got to be using the tricks. Wait for it to load, because obviously there's like a gazillion of them. So the next thing to do is, right, build assets, not it. We're leaving those empty for now. Well, build assets, we probably want to make a directory at least. Oh, it's an interesting one. Build bat and all that. If not exist, mkdir, that's what I want. I need the build directory, of course. Right. So in build assets.bat, obviously want that echo off thing. Right. So it is an extension. It's 33%. So the interesting thing is about that is this is supported all the way from Vulkan 1.0 maybe. Wait, what's the way of saying it? Yeah, it kind of needs Vulkan 1.1, but this device coverage thing is probably talking about all devices since 1.0. So it's hard to tell exactly, like, I wish I knew if there's better ways to source the data with this website. Like if there's ways to sort of say, hey, API version is greater than whatever, but I don't know if there's ways to do that. And then get some better numbers, But yeah. So especially reference the global namespace. Right, so I'm gonna do that sort of like echo off. And then build assets. We want to also make the the asset directories. These are like built assets, basically. Something that we want to do. So there's probably a -p command, but I don't know. So on Linux, we just want to say, obviously, bin sh, and then we want to do like an mkdir -p build assets. That's where the build assets go. Then we'll have all of our separate. So I might move some of this stuff out into here before we have like build system, just to sort of like kick off all the assets and stuff. You just do it all in here for now. Maybe we can get it to do all the files in a directory as well. That'd be interesting. So we've got those set up. We build the tools, and then we could write the code gen file. That's the one where actually, right, so code gen, it needs to, again, bin sh. We just want to launch off, build encoder code gen, and then entity code gen as well, right? So we're just doing that same. I've got to do backslash, and then same thing. So yeah, we much prefer we just had a C script that we built and ran for these things, but that'll come later. Echo off. So on Windows you just do that, and I guess we'll do backslashes as well, just to make things say okay, and then we do the hats for the new line. Okay. Cool. So let's try and kick some of these things off and see how well they go. Okay, so now we've got the new scripts. Oh, I can delete the old ones. So I'm trying to delete encogen.bat, encogen.sh, ncgen.bat, ncgen.sh. Nice. So now I've got these sort of like build tools. So we delete from the build directory as well. Let's delete the old ncgen codegen stuff. We tested the game runs now under the new thing, which is great. And we can now say scripts, build me the tools, please. Oh, I've got to chmod a plus x these things, because I must give them executable permissions and things. Execution permissions. So build tools.sh. Right, so scripts, build tools. Right, they run okay, which is good. And then now we want to run the code gen.sh, that generates all the entity code generation and the encoder stuff. And what do we know? We have a blog. So I probably have one of the paths is probably wrong somewhere. So main at 16. All right, so we'll look at this. So which one of these is it? 5063. So specifically on game material. So and then it's saying like, hey, there's nothing kind of loaded, I think. Did it try to parse and it was empty? Oh crap. So I guess it parsed the database file. That ended up being empty or something, and then it was like, right. Yeah, so if I fail to read it all in, right, what's a failure? File doesn't exist. Right, okay, okay, so if we fail to read, it should, oh, it just returns, doesn't it? Great, so we should actually exit with error. Well, hang on a minute. If it doesn't exist, okay. code game material. Oh, module. Modules. Yeah. You know, you do kind of want it to run if the file doesn't exist as well. Oh crap. I'll rebuild the tools now. Nice. So regenerate all the code. And hopefully the game still now builds and runs. Oh yeah. Nice. So I believe, look at that bloom. Yeah, that's great. Cool, so we're in a good place now. So I think that's the whole restructure of the code base done, and we can move on to now the planning section of this stream. Material plan. So we did this tools thing, right? Create this assets directory, I guess. Yep. So let's do this massive, let's git commit. Yeah, the spaceship operator. Yeah. Just need a takeaway, right? B take A. Does the job. Just gotta remember which way around it is. Bomb, bomb, bomb. Yeah, so we did a bunch of renames, and then there's a bunch of modifiers apparently as well. Like, you know. So let's git add. Let's just add it all in there. The problem is this damn old directory. Oh, did I have it in the git ignore? Hang on a minute, I've got to do it. Because it's ignored in git, I can't. Right, I had a git ignore here for it. Okay, so we'll... So that's my old version of the graphics where it's just got... You know, it is in the git history, but it's just so much easier. It's just there as a file. So I just have it there just in case there's anything else. But I think I don't really need it there anymore, to be honest. But we'll keep it there just in case. Oh, I did that. I completely fluffed that. Cool. Right, let's just get out all of that in there. Let's take a look at all that just quickly, and then we can move on. So we've got that test JSON in there as well. Screw it. So it's just done some renames and that. All right, renames. New files are here. Yeah, let's get them in there. Cool. So git commit, rename. Okay, restructure project, I guess. So let's just quickly list it out, right? No more engine folder. Separation, as hard to know what is an engine module and what is a game module is sometimes. As it is sometimes hard to know what is an engine. module and what is a game module. So there's no more separation between these things. Special for me is apparently only useful when I'm checking there are 2 pointers. Right. I thought it was only useful for the sorting algorithm. Is he good? Does it help you for sorting? There's no origin folder anymore. There's a, new modules and apps folder. And what else? There's like we've sort of tidied up or organized the scripts. And that's kind of about it. Let's just put that in there and move on. Right, so I'll push that up later after the stream. We've still got more things that we want to do today. So, I think what I'll do is just take a quick little break, but when I come back, we're going to go over the whole plan for probably February, probably March as well. So I want to try and find out everything to do with this material editor that we want to build and try and find a bunch of random stuff that will pop up while we're developing it. We want to think it all the way through and decide kind of ahead of time on things we want to do, things we don't want to do, and see if there's anything that will just pop up, basically. So we'll start off by, I guess, talking about the editor itself and drilling down into sort of how it will work and stuff like that. Or maybe the other way around. We'll see. We'll see. Maybe I'll go over what I have right now and then we'll discuss. Hey, Majestic Mac, how's it going? Welcome back. How are you doing? Right, I'll be back in just in a couple of minutes. Just going to get another drink. Maybe get a tea, get a nice big water. I'll be right back. Right, welcome back everyone. How's it going? Got myself a nice ginger tea. Oh. Right, the boys just started crying actually. Let me go and just attend to him. I'll be right back again. Right. BRB. Right. My wife has got the boy. She was going to pop out, so she gave me the monitor, but she's come back again, so that's alright. So, where was we? So, talking about the comparison of pointers, right? I still like to do the sorting with bitmap and swap technique. Right. But with pointers, you'll still get all the info you need in user space as the app with a single comparison, since comparison goes in order of high address space, same address space, low address space, canonical highs, canonical same, canonical lows. I have no idea what this is. Bitmap and... I've never heard that terminology before. I'm confused. Okay. So, we want to build like a full-on proper material editor this time around. So the idea is you can build, like, so things we need to add support for is kind of these sort of like different shader packs that you can load into the GPU system. We've only got really one SPV file right now, and the idea is I want to make it such that we can declare these sort of like proto materials, and these proto materials will just declare a bunch of inputs. So like, hey, I've got this color, or I've got this float value that you can use to config, that you can use to sort of change this essentially material texture like script which is running, and it's just gonna essentially change how like properties about it. So just some clear examples of what I mean. I'm thinking about, we can have these sort of like proto materials for building like wood, that sort of bark, or wood for like planks, or maybe this sort of like volcanic ground. And you can imagine there's a whole bunch of properties you can control to sort of get different bark wood textures, or bark or wood plank textures, or maybe there's a more generalized version that you can get multiple different ground textures, and it could even go into looking volcanic just by changing some of the sort of emissive properties about the cracks in the ground or something, right? So it should be quite powerful, and it means that all in the editor will be able to basically declare these. We'll be able to declare these sort of proto materials that will then be used to make many different materials. So a material, so it might be easier, shall we say, to just start off by just write out some of this here. So we've got there'll be this material asset, which is the final thing the game loads. It's just going to be a bunch of packed textures. So this is the material.mat file. It's just tar bunch of different files. This will be like albedo.pixels, where it's just raw pixels, but later on it'll be block compressed. So albedo is just for that base color. Emissive for that sort of, like if it's a glowing object, you want some emissive, right? And then an emissive strength. Because we're not doing like a HDR texture, right? We're just doing it as a sort of an sRGB base color and it's scaled by the strength. Then emissive and roughness will be crammed into a single texture because they're basically used at the same time anyway. And then probably a height map and a normal map as well, so we can get some really, like, some extra detail on the ellipsoid, which wouldn't, so it's just not this sort of nice round thing. We could probably get some like grooves in there and stuff. So we need to procedurally generate these and things like that. So to do so, we'll have some sort of like proto material, which is going to be, so this is like this can be known as some kind of like, this is a baked asset, shall we say. This is generated from a .mata file, so material asset file, I guess I'm calling it. And this one's going to be a proto mata file. And so all this is going to do is just declare a bunch of like, this is going to say like, hey, what is that? Can I have what's that SPIVI file where all the functions come from? All those shader functions that generate a bunch of textures. So you literally just get away to a bunch of shaders that can just run and they generate textures, and the other shaders that generate textures can just use the previously generated textures within this proto material to then output the final textures, which will be albedo, emissive, and stuff like this. So there's going to be some kind of like shader stack. So it's kind of like an ordered list of shaders that run. Right, it doesn't have to have the best synchronization code. All it has to do is put a pipeline barrier down in between all of them, because it's just ran for build times, and you're talking about microseconds or probably milliseconds that you'll lose, right? Not the end of the world. Links allowed? Sure. Links are definitely allowed, as long as they're on topic. So we sort of reference, so maybe we don't reference a SPIVI file, but implicitly, so from the name, well, I gotta be careful. Yeah, so from the name, so implicitly linked to a SPIVI file with the same name. So there's going to be like an order that they run in. Then also it's going to have a list of inputs. So list of inputs, so this would be like color inputs, this would be floating point inputs, integer inputs, so you might have like a noise. You might want to generate some form of noise, so you might want to have like the number of octaves and stuff like that controllable. And maybe you want to plug in like two different colors, and there's some like interpolation between those two colors, or one color is for emissive, the other one is for albedo, kind of, but stuff like that. Or there's like a sort of a different threshold of colors, like in a sense, if you do like sign distance fields and stuff for like, not sign distance fields, I mean when people do noise to generate like landscapes and stuff, sometimes they say, well, if it's below a certain threshold, it's this color. The inputs can be whatever you want. And the inputs as well can also have default values, so that they have default values, so that when you make a new material which is based on a proto material, it will just have good default values, but also means that we can generate some thumbnails for this proto material so we can see what it kind of looks like initially. And also when we're building the proto material, we get to no. Yeah, so I think when we build the proto material, we'll have a separate thing in the editor, so we're allowed to actually view it and play around with the inputs, that's for sure. But that'll be independent of the default values. And yeah. We'll also have hotcode reloading as well. So we'll be able to see things live and be able to look at all the textures and everything. Now, I don't know what the final projection will be, since it is like an ellipsoid. I don't know if we're going to do like a sphere map to a sphere texture map, or if we'll do like a kind of, because you can do like, the problem is around those, yeah, we might want to do this sort of like, it's not really good because the chat's on that side, but we might want to do this sort of like correction to it, or maybe offer a function to do that, or maybe do a cube map kind of thing instead. And you can use different, there's like a octa, it's not octa, is it? But yeah, we've got to play around with different projection modes. I do not know what there's a few different ones. There's like octahedral mapping that people typically do for probes. This is it. They often do this for like probes. So the problem with this one, if you want to do repeating textures, you have to fill in extra border pixels. But yeah, this is another way we could do the store them in here, or maybe we could do dual polaroid, I think. But yeah, something we've got to just have a bit of a play around with. So I'm not sure about the, I guess let's keep a thing jotted down here, is I don't know what the final, what is the final, what is the sort of projection of textures will either be, so we've got spherical projection onto a 2D plane, right? We've got, what was it called again? Octahedron, or hedral, I guess. We've also probably got dual polaroid, maybe. I can't even, probably pronouncing it wrong as well. Paraboloid. That's it. Oh, words. So this is another mapping that they typically use for like environment maps these days. It's another one. Maybe this is another one, we'll see. So one for the top, one for the bottom type of thing. So maybe that's a mapping that we can use. We've got a bit of a play around with that. And we're going to stick with one, because if we don't, it's going to make the shader sampling code have a switch statement in it. So we just got to pick one. I was referring to this type of sorting, right? Bit set sorting. There's a very quick sort, specifically block, right? Carefully written partition function to let the compiler generate SIMD instructions without actually writing SIMD strings in the loop. Right. Okay. Yeah, I don't really know much about sorting algorithms, to be honest. I know about a few GPU ones with like radix sort and stuff like that, and there was the other one, Bitonic sort on it. But how are they also generating the SIMD here? It's a bit hot. Oh, it's the it's the vectorization, isn't it? Right. So they're relying on the fact that it auto vectorizes. Interesting. Yeah, I don't really know too much about the SIMD stuff, but the specifics. I can read this code, but I don't know why that will. How that will help in the sorting algorithm. But that's interesting. Like a SIMD sort. Well, to be honest, it wouldn't be surprising because the GPU sorts are SIMD. I wouldn't be surprised if they would have done, have something similar. Okay. So projections, yeah, still an open question. We've got to figure this one out. Just got to have a bit of a play. So those are the proto materials, right? They're just a ways of declaring. Oh, that you probably want a list of textures as well. A list of sort of like textures you would like to generate and what sizes they need to be and what format maybe. Yeah, list of textures. So it'd be like probably a format, dims. Okay. Right. And obviously there's a bunch of built-in ones for instance, albedo, emissive and that you always have those. Nice. Okay. So the next thing would be you've got the actual material asset itself. So I guess this is the baked material asset .mat. Then this one will be the MATA file. And this is basically, aka the dot CSON file. And these are all CSONs. So what is CSON? It's just my custom C-like JSON thing. So I've got my encoder system where I just declare a bunch of things. So here's like an old material thing. I can declare like kind of these C-like structures of things, and it's to do with like encoding and decoding stuff. It automatically generates the code to encode and decode these things. And it also does type information as well, which I try to use sparingly. But I have to use it for things like where I don't want to code generate a whole bunch. So all the serialization is done with code gen, but all of the sort of other stuff is done with type information. So this allows me to sort of like declare structures of files that are on the file system, or maybe even just code generate packing, and this is the sort of packing syntax. Maybe ways of specifying packed stuff that will co-generate it all for GPU as well. So it's used for that as well. And it does versioning, it doesn't, you can opt into doing versioning and stuff like that, basically. So CSON is the text format, but there is a binary format where it's just literally a mem copy. And stuff like that. So in this one, this just sort of references the proto material that it is using. And the thing about it is that it just has is a list of input values, right? So this is an input sort of spec or definition or input description, I guess, descriptions, and the default values. This just it's like an instance of that, right? And provides their values, and then this is what goes through the builder, and it'll just run the shaders with those values, and you'll get your material. So we'll build some editors around these two things, the proto material, so you can help make these sort of programmatic materials basically, and then a actual material which will just tinker with the values and you get what you want. So this is all done at build time, no runtime configuration of these variables. So let's just say it's build time or editor time. What else is there to do with this system? So, okay. So I guess that's a good rundown there, a good high level rundown. So now I've got to figure out how we're going to achieve said thing based on where we are right now. We've got 12 streams in February. Probably going to take more than that. So I've already done this restructure the project. I allocated one stream for that. And we're going to spend the rest of the time just planning out everything. So the GPU system right now, it only has one SPIV file that we load in, which is great. All the shaders in one SPIV file, but we're going to want to make it such that, you know, it will just be a bit, if we had, like, these are kind of like assets, these sort of materials. It would be great if we could make these separate from the code base, all of these materials. There might be some sort of like shared material library that gets included, but it should kind of be separate from the game code, I think, because it's just sort of like a build. It's only done at build time and for actually making textures and stuff. So if we could make a sort of separate system, which is a separate library, maybe in the future, I'm leaving the door open for like, maybe if you want to make like a mod for this game or something like that, or custom models and things, but they want to make their own materials. Well, if we're building this all into the editor, why not just try and help expose that? So let's do the sort of groundwork to get it kind of working, but not just go the full way where I need to. Yeah, we tried to do most of the work under the hood. That would have to be done if we were trying to support this, but just the final bits at the end I'm not going to do. So we have a separate SPIV file that will live next to the proto material. So we need a way to load these sort of custom, these shader packs at runtime, and they're going to take in a list. You see, I wonder, do we need a list of shaders to load? So the way it works right now, go into the Vulkan code base, create shader module. So create one shader module where we just put in literally shaders path, it's in build shaders or SpearV. That's it. One shader module, it's got them all in there. And then we just go over all the pipelines, a list of the shaders, and compile all the pipelines, right? So this code just needs to come out, and we can make it such that we can, we want to pass in a list of shader entry points. So it's just, like the main functions, essentially like the compute shaders, right? List of those to compile as pipelines. So it'll pre-compile as pipelines, and then when you hot reload, so when the SpearV file changes, we'll have probably use a timestamp system, just check every frame the timestamps. When that changes on these SpearV files, we will simply just reload the file, destroy the old pipeline, get rid of the old shader pack, reload all the, reload the file in. So reload the file in first. If it's all good, reload. Yeah, get rid of all the old pipelines and recreate them. Yep. So probably do that in a stream. That's the idea. So we need support for that. So then we have this sort of editor for these sort of proto materials. It'd be really nice just to use and stuff like that. So I need to try and get this in an order that we can actually execute on as well. So after we've got this sort of thing in, it might be wise, it might be wise that the renderer probably gets sorted out as soon as possible, because before we do anything, let's just do all the sort of groundwork for the renderer so it can sample all of the textures and gets the albedo and emissive and metalness and roughness all from a texture. And then it's just a case of whenever we get these things generating in that, it's all that's all ready, right? We don't have to sort of like try and do something else to get it all up and running. So I do have these down here. We'll get to the editor side of things in a minute. So let's put these here. So we might need some kind of like texture caching system or something like that. So like I doubt we might be able to have all the materials loaded maybe for a whole level. You might be able to say like, hey, there's only this many materials you can load. Or maybe we'll sort of like stream them in based on when they're needed. And we'll probably need a place to store a bunch of thumbnails as well based on when they're needed. Like when a UI tries to render and it's trying to put a bunch of thumbnails in there, how do we sort of load those dynamically and get those? It's easy when they're pre-generated into a single file and all of that, and you've only got so many of them. But when there could be a dynamic amount of them, yeah, it'd be a bit fiddly. So we probably want some kind of like cache where these will just be a sort of like a texture array, texture 2D array. And so all the materials will be in one texture, or a couple of texture 2D arrays, I think. And they'll obviously be bitmapped as well. And you'll load them in at different resolutions and such. So the texture cache will return probably like an index and a slice. Returns a texture index or a resource ID and a slice. I think I call them layers in this. And a layer index, right? What array layer is it on? I think that's what I did. What did I call it? Layers? Yeah, I call array layers. Okay. So that means in the shader code, we'll pack into a single U32 still. The layer will be in the high bits or something. And then in the shader code, you need to cast it to a 2D array and then do a sample or something. Maybe we can make a function for that to make it easier. I don't know. Oh, that was strong. Oh, that was strong ginger tea. Oh. So, yeah, my only concern is right now in the Vulkan code, when we do our pipeline barriers, we do it for the whole resource. And if we are... I want to be careful with those layout transitions. Like, see here, the sub-resource is just the whole thing. Now, we might want to change a particular array layer in the case of the texture cache, because each array layer is essentially a different texture. So we might have a 2048 by 2048 texture, a 2K texture basically, right? 2K resolution, and then we have like a few of those, and then we have twice as many 1K textures, and twice as many 512 textures and so on. So you might start for like 2K textures, 4 1024 textures, 8 512 textures, 16 256 textures, right? So we'll have different, based on how sort of close these are to the camera or whatever, they will get loaded into these, and based on what is available. Something like that. And that'll happen automatically when you request a certain material to be loaded. Now, my concern is that, this will be one, like each of these will be their own texture 2D array. And so this one has 2 slices, that has 4 slices, 8 slices, 16 slices. So obviously when we're using those textures and we upload to those textures, they have to do a layout transition, I think, on the upload. Upload texture. So where is it? Sync resource, copy, right. So when we see these in the Vulkan backend, it's in a pipeline stage on that. So I think we want to be able to add, when you sync on a resource, you want to be able to sync on a particular slice as well. And that's only going to be used by the texture caching system, because the thing is you got to be careful about is if you try and do a layout transition of a whole like, say if you've only transitioned one slice of a texture and you transition the whole texture again later on, the Vulkan layers are going to complain because they're going to be 2 of the slices be in 2 completely different states, and you've got to make sure you transition them all, the previous state is 100% correct. So we've got to be careful about those things. And so we could stick them in maybe the general layout. That might just be okay. See, this is why I'm trying to solve these sorts of problems before, so I don't go into... So is image layout always general? I think it is. If that's the case, then maybe we don't need to care about this. Okay, so the swap chain image goes into present mode, that's okay. So it can be undefined before, but then it always goes into general. Nice. Yeah. Yeah, but the barrier, what about the barriers though? So you put in the barrier and just saying, hey, this whole texture is written to. I think you could be fine. Right, I think we don't have to do anything. Yeah, I think we're okay since we just use the general layout. Okay, so that makes this a lot easier to do. So let's say this takes 2 streams to do that because... So you'll give it an asset, it will check if the asset is loaded already or not. If it's not, it will return, if it's not loaded, it will return a null resource, but next frame it'll be ready and it will load it or something like that. Or maybe it'll load it for that frame if it can. Yeah, something like that. So that's something to play about with. So we've maybe build that in a couple of streams. So the next one to build is probably like, what changes to the renderer do we need to make? Oh, and a thing to note as well is we're not doing any sort of like async loading or anything on this. It's just all single thread for now. It'll be a lot simpler to do. So I've looked at it, there's shouldn't be an issue with pipeline barrier. Well, let me just say, we could say we use VK, we always use VK image layout general. So there should be no pipeline barrier issues with sub-resources. So when we upload and then go to, yeah, renderer changes. So with the renderer, we need to add multiple materials. We've only got one material right now. Let's have a look around a bit. So when you do that sort of like find model, it is kind of hard coded. Final load model. It's kind of hard coded at the moment to a list of models and things. But I guess each model is going to have a list of materials that it uses. So in that case, you need to be able to get a list of materials from the model, I would think. Yes, you probably want a list of materials in here such that you can go over all of the materials that you would need. So you'll get like you could probably work out the height of the model and sort of see do a rough guess of like what level of detail you need loaded for the material, the material, isn't it? So what MIP level you need loaded at least? Okay. So you could probably say graphics models needs a list of materials used in the model. There we go. And then you need to say something like the model, we need to know how big the model would be in So the problem is we do a lot of this stuff on the GPU already, right? We basically we do all the culling on the GPU. When we emit the ellipsoids, we get the sort of like outer AABB. So we could reuse this function, but on CPU. And use it to get the height maybe. But then you're doing that for every single model instance. But then like how would you, before kicking off on the GPU, know sort of like what level of detail materials you need loaded, right? In this case. Well, you could probably get some feedback, but then that'll be like a frame too late anyway, or 2 frames too late. So you might be better off just, yeah. So you probably want to say use this CPU side. For each model instance, use this CPU side to see how big the model is in pixels. Use this to work out the level of detail for the material texture cache gets. So you'll give it an asset and a sort of level of detail that you want it at, and you'll get back you'll get back one of them. Yeah, sorry, you'd either get back a valid texture or an invalid one because it's still loading or something like that. So we need to work out, so all the materials that so there's a list of materials, right, of like of assets basically. So you want to build a deduplicate array of assets. So the issue is, right, so yeah, I guess when you have like a level kind of loaded, you're probably going to have a preloaded list of materials anyway. But all of them might not be loaded yet per se. Okay. Yeah. So so when a model gets loaded, okay, so we'll probably have a material. The graphic system will have a sort of like material pool, right? Which will, yeah, okay, we'll have a material pool which will be mirrored that each model. So when a new model is loaded in and references a new material that's not been loaded in yet, then we will allocate a new slot for it in there, and then that's what it'll remap it into. Okay. That'll be mirrored to the GPU. And so this means you'll have like a way to take a asset. What do we have in this code base? Assets. So an asset ID is that it's open. We might do the hash then. It doesn't have to be open. Yeah, so you have a way of taking the hash and turn that. So you need to have a function, right? Function for taking that and then getting back a material index. Right. If it's loaded. If it's currently loaded onto the GPU or something like that. That's good. Okay. So the model will have a list of... Right. So the model has a list of... It kind of has like an asset path, maybe. Yeah, what was that hash thing? Yeah, so it's probably going to have a list of asset paths for now. But later on it might... Material asset paths. And then when it on load, it will basically get or insert the material pool from the material pool. Now the thing is like when it does that sort of get all, at that point the texture cache will have to get called, I think, and then it will. Yeah, we can work that out. Okay, so what else will have to get done? So it goes over all of the model instances, checks their size. And then yeah, maybe you want to have a way to say, so you can just have a get function. Right, then probably at the end you probably want to loop over the material pool and create that sort of graphics material, or upload the up-to-date graphics material texture IDs basically to the GPU. That makes a lot of sense. So this one we want to say, it doesn't probably get the textures, it just wants to go over all those materials that are found. And I guess if the material isn't loaded, yeah, you want to be able to say, if the materials haven't got a text yet, don't render the model, probably. The material, and ask the texture cache for a texture at this LOD. Yeah, you want to say, you want to check, you want to say request the texture and then it will return it can return a lower. It can return lower LOD, but will maybe load the higher LOD for the next frame. Or something like that, right? And then if it returns but if it is not loaded, it will return. If it is not loaded, then it will return 0, which will mean we will skip rendering the model. Something like that. Maybe there's a thing we can do where we can say, we can see, it's difficult to know. Yeah, maybe we can put a max limit on a level and say like, at most you can have this many materials, materials, and we just preload all of them, right, at the sort of lowest resolution, right? That way things will at least render. And things might just disappear. That's probably a better idea. Yeah, so maybe if you have a model which is loaded, okay. So say if you had like 1,000. No, what do you want to do? Mm. Yeah, so you could probably do those sort of like 64 by 64 or something like that. And there's just enough of them. So just preloads all of them at the lowest resolution initially. Yeah, so we could say so I guess what's the problem with this system? If we have like a level then, and you put a bunch of model instances down, right? We'll have to keep a list of like what is the for each model instance on the scene. You know, deduplicate all of the materials, and if that goes over a certain number, it's a problem. And you can always then change the sort of like model instance and reduce the number of materials for that instance, and it will have to get recalculated again. So that's another problem to sort of solve. Whereas if you just allow it to not render, then maybe you'll start get sort of some flickering stuff going on, right? Which is pretty much a no-go for rendering. You don't really want flickering or anything, right? So it would kind of be nice if there was, or maybe it could just allocate another texture to sort of load them in on, but you kind of want to avoid dynamic allocations, or at least I do. So maybe what we can say is there will be enough room for the sort of lowest resolution texture 2D array, material texture 2D arrays to store for the whole level. Right, maybe there is a maximum limit of 1024 unique materials, and the lowest resolution is 64 by 64. I don't know. Let's just pick one, and that way you at least see something. It might look a bit trash though. I don't know what are the restrictions on some of this stuff. So we've got like the properties. Yeah, there's like array. There's a limit, right? For the array layers. Okay, so 1024 is alright. There's not really that many that support less than 1024. It's about 2000, right? 2048. And the rest, yeah, the majority of them are that and above. So 1024 is probably okay. But we can you know, hardware, Vulkan survey. Don't need to spell stuff, but there you go. Survey says 2048. Most cards these days support 2048 array layers. So maybe do that. Okay. Good. So we're going into lots of detail, but this is great because we're figuring out some of these problems we should just be able to execute. Right, so for each one of these, you will never skip rendering a model now, right? Which would be kind of cool. Then we loop over all those materials that are currently loaded in the material pool and upload the upstate texture IDs to the GPU. So we'll probably have a bit of a safeguard in the code to say, well, if we can load all of them, we'll just swap it out for the wrong material and just let it use the wrong material. And we'll probably put a log in there or something to catch it. There's some catastrophic problem, but it still carried on. Stuff like that, because we don't really want to crash the game. So, oh yeah. Make sure we make sure if we don't have enough room, we use the wrong material and log a big problem. To remind us to write, because this would be quite a lot in the future, I'll probably forget this. So it'll remind us to write the code that checks that a level or whatever is restricted or has no more materials than the limit. So that's what we'll roll with for now. It'll be pretty ideal, hopefully. Nice. So we loop over all those materials in the material pool and upload them. So that's all the CPU side stuff, I think. And GPU side, we've just got to change the shader code. So it's called in shaders calc surface color. This is all the PBR shading code. We've got these structures where we pass in like the vector towards the camera, that surface hit position and the surface normal. And then there's some hard-coded lights and stuff. So it does it all in here. And effectively there is if we just have a little bit of a look around, there is the roughness and such. Here they are, material. Yeah, so it's the albedo, emissive, roughness, and that. So that's just passed in from the CPU side, but they're going to be textures instead, right? So we've got to somehow okay, so the material is passed in, so we'll have to somehow, when we get the surface hit, can we how do we sort of unwrap that texture and get the values out for that hit, right? So there's that sort of stuff to figure out. So I guess we're doing the projections at this point. What projection modes do we do? And we can maybe get some sort of texture and play around with that or something. So, okay. And we're also going to upload them from the CPU as well, get some sort of like test. Or maybe we just use like a red color and a green color for now. And don't really care so much about it. Just at least get the code at the ready. Yeah, I wonder what projection modes would be good. But yeah, we'll see. So I want to do more things today, so we can ask this question when we do it. So we need to write the code where we say shader So I guess we say this is the CPU code. Let's move all this in here. This is the GPU code. We need to be able to like sort out those. So when we get the hit, how do we turn that into UV? So ray hit, turn that into a UV. Then we also need to calculate the MIP level based on the derivative of the UVs across the quad. Then we need to actually do the sample the textures. Sample the textures to produce that material that gets passed into for the values that get passed into the calc surface color. Right. Nice, so I think that's it. So should it take a couple of streams? Maybe. Let's say it takes two streams. One for the CPU side, right? So that material pool stuff. Go over the list of materials in the model. Let's be hard-coded for now. And yeah. Load from the texture cache basically. And then go over all the model instances and just make sure just tell the texture cache what sort of level of detail it's kind of wanting so it can sort that out the next time around. And then loop over the material pool and upload that. So only sort the buffers and things. So let's just say that takes a couple of streams. It might take 3 streams, but it just takes 2. Should be okay. Right, so now let's get on to sort of like, so this is to actually get it working in the renderer. And then everything else is kind of like the innards of the editor, the low level part, like the behind the scenes part of the editor, and then also the front end with the UI and how we want that to behave. So, right. We probably are better off trying to get the material builder and all of that stuff running. So let's just give a brief recap for those who are just joining. There's a sort of like proto material where it basically implicitly links to a SPIVy file. There's a stack of shaders, each will generate a different texture. So yeah, maybe there's a shader /texture stack. Right, it's like it has a name, and then it sort of optionally has a format and dims depending on whether or not it's a built-in one or not, right? And then list of input descriptions, so like a color, float, or integer. So we can use this to sort of procedure generate a material at build time or editor time. And then we have sort of these instances of that proto material that just reference the proto material with a bunch of input values. And these are the things that get run through the material builder. So the material builder, this is about creating those encoder files. So how they are, like the description of those, it has like the name of the, let's get some of this stuff in there. Whereas the name is inputs, default value, shader name, no. We'll change how that works now. This will allow the engine to load up the user's proto materials if we allow this later on. That's good. The file extension will be It's just a CSON file. Right, it's using the encoder system. It's just the text document output. C like JSON. And the extension will be proto-mat A, or proto material asset. And then we want to create a graphics material. Gotta be careful here, right? See, I could use the encoder system to do the, rather than using tar though, isn't it? So these are the assets, and then there's a baked asset. I don't know what benefit. Sorry. Oh. Oh, I get it. Okay, so there's this sort of like baked asset here with, which is just a tar file. So I could make this the sort of encoder file where we literally just declare like, yeah, I guess what benefit would it bring? If it was an encoder file, you would just be able to load the whole thing into memory, and you'll have all the file offsets. I guess, so with the encoder file, there is an example somewhere, I think, in test. No, that's the CSON. Yeah, so here's an example, right? We'll be able to have this, the root structure here. Right, and you know, this is not limited to the root one, but you can have these variable length arrays. So we could just declare like, hey, this is the image data for the albedo channel. And then we can literally just declare that, and then we'll load this. You get pointers to this structure in memory in C, and I'll have a couple of macros to help you get to the start of these arrays very easily, because these will be compiled to a 32 bit integer, and then so just offset from the start of the file to the right place. And that kind of would be better than tar, as in it won't have like strings in it they have to look up and stuff. Like why would it need to do that, right? So maybe we don't use tar actually. Why don't we just use a yeah, so it's a bit like the baked asset then. So yeah, we need to be careful about, hey Tempvar, how's it going? How you doing, sir? Good to see you. Yeah, so maybe this is just another encoder file thing. Like why isn't tar? Doesn't make any sense. And I guess we can version it, and it doesn't need upgrades because it's a baked asset. So yeah, that'll be good. Yeah, exactly. Why are we doing that? So in this one here, the proto material is fine. The thing I just got to be careful about is like, so in the game, there's, so we want to have like the baked, this is kind of like editor level assets, and they're not really the sort of like, so I could call it graphics material textures when it's the final textures, or I call it graphics material baked when it's actually the baked material. And these are sort of, and these ones are descriptions. I can call them yeah, okay. So I guess we'll have another one where it's like, this is the baked one. You know, it's just a bunch of VLAs. A bunch of VLAs of texture data for, you know, albedo, emissive, etc., etc., right? And that's all it is. Yeah, that'd be ideal. So we'll just do that. No need to bring in another dependency, although microtar is very minimal and very awesome. Just don't think I really need it. So that will then mean yeah, I'm just concerned about these namings still a little bit. We could start off with an E for like saying it's the editor asset. Like an editor asset or a like an E and a B sort of prefix. We've got sort of A at the end for saying asset, but you know, so I could say baked material, and then you have like a E material for editor material, or S material for source, SMAT, and BMAT. This is the way. Yeah, baked material, asset maybe. Or maybe you call this so there's one which is called a proto material, which the material references. And also when we do sort of models as well, we're going to have a very similar thing, right? You make a model using like we have an editor. Oh, that was another thing we was going to do as well. We store the whole edit list, the whole history of the whole thing. Like we did that for the original material. Like rather than just storing the input values, we just store the whole history of it. That way you can boot it up and just see what it looked like before. Right? And see how it's changed. It's another interesting approach. Well, at least for the material that will make sense, but not for the proto material, I don't think. Because that's going to be dependent on shader code actually being. Yeah. Yeah. So maybe we can say it's a list of input. It's a list of input value history. So it stores, you know, it's great when you open up a text editor and it's got your undo history in it, right? That'd be ideal. And the default values would be the first so many entries or whatever. Be cool. Input values that match the expected input of, yep, stores the history of input value changes, and this gets evaluated, you know, the file in or whatever. It's pretty nice. So we're gonna have this problem where we're gonna have a baked asset for the model editor as well, because the model editor is gonna have again a list of changes. So like, you know, you can essentially watch the model be created over time. From the beginning. You can also like watch it, you can also undo it. You can go back in time and see what it was like before. Right, I made this change and that change. It's quite ideal. It's just like, so that they will be baked into some other format, that is for sure. So we should really try and standardize on something for those two things at least. Right, so there's also another thing I wanted to remember as well. It's to do with the material. What the properties was it? Oh, I forgot that now. What was it? I remembered it when I was around here. Baked material. No, I'm not remembering it. Alright, we'll see when it comes back. So let's just sort out this naming. Very important thing. So do we call them a baked... Has anyone got any ideas around this as well? These sort of baked material things. So I could just call these sort of like editor materials in some way, because they are only really used for the editor. So we can call it ed. Always start them with ed, edmat, editor material. Just makes sense, right? What it is like before. Ed proto material. I call it pmat. But proto mat would be better. Bit long though. There we go. No A at the end anymore. That's wise. So I think we'll live with that one. Then we'll call it a .mat file for a ed mat editor material. It's distinctly different now. Ed proto material. Alright, I'm happy with that one. Okay, so anything to do with sort of like, so the next task after always renderer changes is to do the asset files. So there's 3 of them. There's the proto material. So we can call this the graphics editor. I can call it by its extension. No. Editor proto material. Editor material, and then this is the baked one. Right, so I put one stream in for that. It's probably going to take a couple. I don't know. We have just got it all listed out here though. It's just 3 description files for data structures. Might be able to do it in one stream. So it's the sort of like... implicitly linked SPIVy file the same name. The shader texture stacks is a list of names and format and texture formats and dimensions. List of input descriptions like color, float, or integer. Right. So, oh yeah, that's what I wanted to remember. So, if this proto material was to change, like you've changed the proto material, so if you remove a property, it will just invalidate. Yeah, it's kind of a very big behavioral thing. We just got to remember to write down here. The proto material in the editor. If you remove, so update, just put it this way, there'll be an editor where you can just sort of go in and just change the proto material, and that will then kind of invalidate the other materials and those have to get rebuilt again or whatever. So if you build, or if you sort of update the input description behavior. And that is like if you add a new property, should we say? I could probably just call them properties. If you add a new, I don't want to call it edit properties. Rename that. Property value. I guess that one in a bit. Cool. So if you add a new property to the proto material, it's just going to use the default, right? The existing .ed material files will just use the default value. And then if you remove a property, right, the existing .ed map files will just forget that property, basically. Forget that property once saved. So you could do a thing where you remove it and add it and all this. I just don't want to do any sort of versioning thing with this. So that'll just be the behavior that we get, and we just got to be careful about such things. Because you might, or maybe we could say you can never remove a property, but then like, so if you say you can never remove it, how are you going to track that? I guess you can make it in the UI so you can never click remove. Or maybe you can say remove, but it never actually gets removed technically. It's just a hidden one. So we could say, yeah, then whenever you bring it back, you'd have like the value would get preserved, maybe. But then it might kind of mean something else. Another thing. Yeah. So you just have to be careful when you update the proto material and you've got a bunch of materials based on that. It's going to make them look different. So you really have to be careful about that. So we have to have ways of being able to find all the materials that are made with it and to be able to check the changes. Yeah, it's got me thinking maybe do we need a system to sort of like, well, we've got thumbnails, right? So I guess you could compute thumbnails and sort of just view how they change between change. Yeah, it's a thing to think about. So we're making like thumbnails and things. They could get checked in, and then theoretically you have a history of these things. But then like, if they get checked in and you haven't updated the files, then they're in different commits and all this stuff, right? So it's a bit questionable how we handle that one. Okay, we'll think about it. Okay, so what is left to do? So that one was declaring these. So we'll just take a stream, right? three data description, three files for three different data types. I think that shouldn't be so bad. We can do that, I think. Maybe it'll take two, but it should be one. Then we've got another stream here for the build functions, right? Okay, I'm just going to take a quick break. Just need to get another drink. And then we'll go over the rest of this. Hopefully you have enough time. And so we need to plan out the build functions for the new material builder, the application, what that sort of looks like. Then probably talk about the editor as well, what features that will have, how many streams that will take. And talk about the different sort of proto materials we want to build to test this whole thing out, and talk about thumbnails as well, because thumbnails will make things look, well, be usable basically, because if not, without thumbnails it will not be usable. And then we can figure out how many streams this thing will actually take to build overall. Right. BRB. Right, welcome back everybody. How's everyone doing? Hope everyone's having a good weekend. Right, we're nearly there with this massive old plan. Well, medium-sized plan. So we're gonna have this sort of like material builder. Now it's a module, but it's also an application. So there's a module part to it because the editor needs to be able to like take these text files basically, and then output the image data with a bunch of magic that goes on under the hood. So we basically need to isolate those parts into functions that will get called. So we're gonna have this sort of like CSON file. So C like JSON. So right. So it needs to be able to load in the editor material. And also we need to be able to load in we need to load in the proto material as well, because we can generate we need to be able to turn we need to be able to turn a proto material into a material, right? You know, using the default values. And the reason is because I want to be able to launch the material builder application and say, hey, build me the thumbnails for Wait, could you do that? Where would the thumbnails come from? Yeah. You say build me the thumbnails for. Well, it depends on the projection mode, right? Actually, of these things. Maybe the thumbnail will actually be the. Ooh, will be a ray traced ellipsoid, in which we could actually do it from here anyway, because it's just, you know, not that hard to do that. We've written many of those. So yeah, ray trace sphere or whatever, and just show that on the screen, right? Or should render that to a thumbnail. Okay. Now I need a function to create the material textures, because that's the editor's going to need a material textures that it then references. Wait, why would it need those? Oh yeah, to then dispatch and build them on GPU. The dispatch and pass will need to be able to take in the material textures. And then that will need to basically... Alright, it's definitely taken a couple of streams, I think. There'll be a common sort of... This is what I don't quite understand yet. Is how is the input data going to be on the GPU? It might be... It's probably just going to be a generic kind of system. But you can have a list of textures, each pass that runs. So we need to be able to run each pass. I think I call it like a stack of shaders. Texture stacks. So it's like a... Well, it's technically like a shader pass that can output any... It's a shader pass that can output any thing you want, really. So I'm just thinking, like, how would we... Because we could do like one texture at a time. But it might be ideal for it to output like two of them at the same time. And why would you put that restriction if it makes the code easier to write set in that way? Yeah, so maybe you will need a list of textures, and then a list of path. You don't do a list of passes to say which textures you write to. Shader passes stack, texture, textures. Name, format, and dims. And I guess there'll be some sort of built-in ones, maybe. Texture list of name, format, dims. Right, so let's change that around down here as well, where we basically did the same thing. Right, so back down to here. So you basically just execute each. Run each shader pass with a pipeline barrier in it. Pipeline barrier after each. Just block on all of them. They're in the order they specified in. There's going to be this sort of like shared bundle constant structure now, so you can write to whatever texture you want. And we need a way So the problem is the bundle constant is not going to be big enough to store everything in it. So I'm thinking the constants is just going to store a reference to a bigger buffer, and that bigger buffer just has a generalized. It has an array of all of the textures that you could want to write to and read from, and you just manually get those ones out. They'll be like different. Yeah, we'll figure that one out. So I have like a column that just points to a buffer, to another buffer, to a buffer that holds the textures and property values in a generic format. So you can just sort of cast those textures into whatever ones you want, and the property values will be, you'll be able to read from those dynamically or something. Or that maybe there's two buffers. Yes, right. So a common bundle constant structure which that holds a buffer of textures and another buffer of property values in a generic format. Then after you've ran all of those shader passes, you basically just downsample the PBR textures, the result PBR textures, and so that's all one function does. Now, so they'll be sort of in GPU memory. Now, what we need to be able to do is take those we need to be able to take those materials and actually like yeah, so destination textures. Okay. So maybe you don't need a function to create the destination textures. Maybe you do. So that texture, yes, I guess the editor will point it to the texture. Yeah, the editor will pass the texture cache textures in here. So to update those, and then you will obviously render that on the next frame anyway. That's pretty great. So you won't have to sort of like reload the asset in and upload them. We should just be able to put it directly in GPU memory and just see the changes happen live without doing any silly stuff. Let's save that to disk and reload. Yep. And then function to save the textures as the MAT asset file. It's not going to be a tar file anymore. We're just going to use our encoder system. We've got that. I don't know why. I'm just used to putting stuff in a tar file when I need to. But I built this new thing now. Cool, so looking at that body of work, load and save these guys. Just put some nice functions for those. I'm hoping 2 streams, right? So turn a pro material into material for default values. Create material textures as a little function to help you do that, so it's consistent. The function dispatch on the GPU. This is not that complicated, right? Yep. Yeah, that makes sense. And then we need to create the... Yeah, that's fine for 2 streams. There's other stuff to happen later. Right, create material builder application. It's just 1 stream. It's just using this library basically, right? Load the editor material in. Create a material texture. Create the material texture using that function. Dispatch the GPU, read back, and then just pack it out. Pack it out into the MAT file at the end. Done. So into the build assets folder. Right. Cool. So there was something else to do with the... Well, I forgot that. I'll remember it a bit. Oh yeah, the thumbnails. Yeah, so we could probably say like we want to be able to pass in an argument. So load array.ed proto material. Okay, and that can use to build. Do you want to build a default material for it? You probably don't. But you would want to build... So if you just generate a thumbnail, and that will need to basically do the dispatch, but no read back. Right, same as above. Okay, same as above, but no read back or MTA file, MTA asset. This is mainly just like right, generate thumbnail. It will need a read back though. Right. Yeah, so you could just generate the thumbnail for that proto material, which would be kind of great. So this will obviously need to have a little bit of a... We need a ray tracer in there with probably 1 light going down or something, you know? So yeah, you know, simple custom ray tracer with the material shading stuff in there. For a sphere. So we can put that in there. So yeah, at this point we'll have the texture cache as well. So yeah, this might take a couple of streams because we've got to, you know, doing another ray tracer just takes a bit fiddly. Especially I've got to probably cut paste that. Yeah, I've got to cut paste the material code as well. Shading code. Shouldn't be too bad. So my concern is now like Spear V. So the problem is when we have these, this uses the GPU module. Yeah, we're going to need to make it such that the GPU module, when we do these extra shader packs, we want to have the sort of the game or the applications like base shader pack must be passed in now, right? Passed in via GPU init. So this will allow the builder to pass in its own shader pack thing to sort of like, you know, so we're writing this sort of little custom ray tracer with all the material shading stuff just all in a file. Done. And that will help do those thumbnails, which would be nice. Cool. Happy about that. Right, so the next bit, so this is before we have any editor front end stuff. This is all like the behind the scenes, basically what we've written out here. Let's just add some of this up. So there's 4 streams there. 6, 7, 8, 9, 10, 11. So it seems like this might take us the whole of February to do. Is just get the renderer changes in, some form of like texture cache, custom shader packs into the GPU, so we can have like, whenever we load these proto materials in, they have their own SPV file, and get those loaded into the GPU, so we don't have, so yeah, multiple shader files basically, the asset definitions, the build functions for the material builder, and the actual material builder application, which uses the part of the material builder there. Thinking about it, this thumbnail stuff actually has to be available in the editor too. So that's a good point. So we can generate generate thumbnail. That will always happen as part of this. Yeah, and then you can read it back. Simple ray tracer, take that line. So that'll be part of this. So I guess we'll do some other sort of shader pack thing or something. I guess later when you boot the system up. So yeah, okay, that's good, that makes sense. Right, so the final stretch is like, how does the editor look? How does it behave? So I guess we can do a bit of drawing. Just install some .NET on a machine, why not? Okay. So the idea is we have a window. The way the editor is structured right now, I think I can probably bring it up actually. Let's see some of the game. So the idea is the editor is always available. Press F1, pops open. You got tabs at the top. I want to make it look nicer than this though. We'll probably have like an icon to say this is a material. And right now you can open just more materials up, and you can close them as well, and having other UI in the way, damn it. But anyway, they close, I promise. And so really that new tab button should actually open up a asset browser where you can sort of be like, oh, what assets do I have available, and you know, can I create a new one? Stuff like that. So what I'd like to do is have some sort of asset browser. So let's call this the asset. Oh, let me just move that asset. Oh, the asset browser. Ta-da! So with the asset browser, again, it's just going to be a new, the sort of the new tab thing. Just where the sort of tabs live up here. So I'm thinking like, so how are we going to design this? So we're going to want to have some sort of filter options for, we definitely need some filter options for stuff like the asset type. So is it a material? Proto materials, another one, right? You know, and etc. etc. We're going to have like models and things like that. So those have to be taken into account. So there'll probably be like a drop down or something. We're going to want to have the ability to obviously fuzzy search. We're going to want to have thumbnails, right? Thumbnails are next to the name and stuff like that. And then we also want to be able to have thumbnail and name, right? A list of thumbnails and names. And then we also want the ability to say basically new asset within there. Okay, so when we have a new asset, it's probably going to want to have its own screen, because when you have like a new proto material, you want it to, sorry, new material, you want to look at the proto materials and be like, hey, I want to base it off that one. And then from then on, that asset's going to be for that thing. So we could just do it where we have like a list of, you have like a search box up top with all the filter stuff. So you could have the sort of the search box here, or the search box maybe at the bottom. And yeah, so you want to be able to find stuff, and you want them to be sort of a decent size as well, and have fit enough of them on screen. Another thing. But they might be in, you see, they'll be in the sort of assets folder, and then materials where the materials go. Well, they don't have to go in there. You could make it maybe a little bit more free with how it's sort of ordered. But yeah, we also have to figure out then, like, as part of this, I guess we've got to make some code which scans the asset directory to sort of be like, well, this is a material, this is a proto material, and these things get, they get indexed for this at least, but also maybe we can use that same sort of code for actually building the materials, right? It's another questionable thing. So yeah, we're probably better off with like sort of like a thumbnail on the left and then probably the name. Some kind of structure like that, or maybe thumbnail then name underneath. And maybe if it's long enough, it's a couple of lines. Maybe it can go up to a few, two or three lines, and then that's it. So we can sort of like do a fixed size, and that way it keeps it so you can have support for quite a lot of them. Although we'll break up the name a bit this way. But you just keep repeating that across, and you have maybe a little search. Maybe you have the search at the top. So you have the sort of asset browser name in here, like browse or something like that. And you could probably put the search box and all the filter options up here. Always look at the bottom. Those are the basic two choices. Lovely handwriting. And then we'll have the sort of filter type. So you have the type. And it's a nice drop down. And maybe there's some other bells and whistles here as well. Maybe we'll make this wider, to be honest. Oh, crap. Eh. Yeah, so search, and then you have probably just the type of asset here on the right. Oh, you might want other little options as well, but let's just like maybe like an ordering, like a sort order and stuff like that. Let's just say it's the stuff like that, right? So you might want like a sort by options as well. Maybe this doesn't actually matter for now, but that could always just be added later. It's not actually too much to add that. So it'd also be nice to be able to, use the keyboard, have some sort of like keyboard controls, because I really don't like navigating stuff with the mouse sometimes. Having full keyboard is pretty good. Which makes me think actually I've kind of got to sort some of that stuff out. So hopefully you can, open up a new tab, straight in the search, type it out, right? We also probably want like a new button as well, like, hey, I got a new asset. And when it comes to deleting them as well, would you... Yeah, it's just having this whole list for search results would be pretty sweet. There's no point really just... I don't think there's really point... You might want some sort of folder hierarchy maybe, but for now, it might be easiest just to show all of them available in here, and you can just create a new one. Yeah, that's probably the easiest thing to do, I reckon. And you want to have probably like a way to say a new asset somehow. Yeah, so that'll be like maybe a new button, and that'll be like a type. Kind of filter drop down box thing, right? This is a new button. Again, that'll probably be another drop down box as well. Nice. So I think we can live with something like that, just to get us going. Maybe it'll take us a couple of streams. I'm thinking about all my editor input stuff though. It's a little bit messed at the moment. Hey Zaka, do you think software project is ever done, or is it never possible to finish something to the maximum quality possible? Well, yeah, nothing is ever done. that is true. You can always get more and more finished with something. At a certain point, though, you will just be tweaking things, and the amount of returns you would get is questionable. Like every time you add a new feature, how much did that actually help in the final product? It's hard to say. Sometimes you just got to try it out and see, right? So a lot of the time, you can actually stop making a game with far less content than like another version of yourself that carried on, right? Because you can always just keep adding new levels and everything, so that just will contribute to, you know, at a certain time, enough is enough. Then also there's a level of like quality that you can always just keep chasing as well. How much, adding more and more features, or yeah, it is. It does. Every project can never end, basically. So you just got to find a place of like, what is good enough, and where are you gonna stop it, basically. And that's the whole art in itself, because if not, you just keep going forever, or never finish anything, because you get to a point where you just give up. So there's all those, or run out of money, right, in the real world. So yeah, that's the reality. So I got a bit of a bigger question around like, my input stuff is a bit messed up at the moment. Like I'm fudging it a bit with some of my input stuff, and I think the way games properly handle it. Did I reach the finished HCC? Yeah, I guess I have, because I'm using it, right? That was the main goal. Like, it would have been cool if it was useful for more people. That's probably the next goal, but it's very difficult to achieve that. Or or the next level would have been good enough that some people would have been willing enough to contribute to help keep it going. You know what I mean? So it's not just me, but that would involve. But yeah. So there's degrees of finished. So first degree is finished because I'm using it. Second degree of finish would have been someone else is helping contribute to it, and therefore helping it be useful for more people, and hitting that third degree of, quite a lot of, multiple people are using it, and it's finished enough for those groups of people, right? So yeah, that's where I'm at in the 2 degrees of finished. That's HCC. It still only supports Vulkan, and we do really want to probably get it to other platforms whenever this project wants to go to another platform. So that will be a thing that will eventually get done if this game ever goes to another platform. So the editor, that's the browser, just a simple thing for now. If we get crazy amounts of assets, we solve that problem. Then we'll have a better idea of what's going on. For now, this is all we need. So keyboard controls. Keyboard. So right now I fudge it. I've got like F3 to open up the... I've got F3 to open up this settings panel. I've got F4 to open up this profiler panel. Right, and I've got my sort of arrow key controls will control this, but if I hold the Alt key, it will... If I hold the Alt key, it will move the profiler around. And it's the kind of thing where we kind of need probably a better system to handle this. Like, I don't really know what a name is for it. They have many names, like a UI stack or a scene thing, or, you know, so when you sort of have a keyboard input, which one of these layers absorbs the input and it doesn't get passed on to the layer behind it, right? You know, because I could, for instance, have this layer up here, and when this layer's up, the game doesn't get any input, right? That would be nice. So it's like, how do we achieve said thing? I think it's something to look into, really. So I think games will use the event loop. Yes, I think games use the event loop, basically. And the problem is if we use the event loop, it's only on a particular thread. And I think I've got my UI. Well, I've only got one thread at the moment, but the graphics system has this sort of like texture viewer that on the profiler as well, that's all done in the future, will be done on the graphics thread. So yeah, perhaps we just do a very simple thing where we have these sort of like layers, input layers or whatever, and the idea would be you never pass them back a layer. So if the profile is up, that's like on the top layer, only it can accept the input controls. When this dialog is up here, only this can take the keyboard controls until we close it. And then the game can only take input controls when nothing else is up, right? Just whatever is at the foreground is the thing which takes the input. Maybe we should build a system in for that. So yeah, and then maybe the settings can only be opened when the settings can only be open when the game is running, right? Because it's for the game. Okay, I think that's pretty wise then. So it's just a case of like, how do I keep note of which one of these sort of views is on top? And where do I stick that? So I think that'd be the simplest system to do right now. And then that will work across threads. You would sort of ask the game, what is the frontmost kind of UI element, if you will? There'll be like a UI stack. And then we'll just have that as an enum that'll go around. So everything needs to have access to that. So that could probably belong to the game. Yeah, we could probably throw that in. It's probably quite easy actually thinking about it. There's something to think about when we're talking about keyboard controls. So we probably want to like add to game/game.h a sort of like a UI. We could probably call it a UI stack. Yeah, the problem is stack is a very general word, but I wonder what they call it, or an input stack. Because I know typically, I think in like Windows, they sort of use the event loop structure, isn't it? To sort of go through all those different layers of things and where the event sort of gets absorbed. But I don't know if that's a wise idea. But if the UI all gets done on a single thread, so we could probably call it the sort of like input focus stack, and I guess we'll just sort of push and pop onto that for now. That'd probably be a good enough workaround. So you can only open up the settings panel when the game's open. You can only open up the profiler. We can open up the profiler anytime maybe, but when the profiler's open, if the profiler, you want the game to kind of be running still. So maybe only when the game is open, you can open up the profiler. But that doesn't steal away the input focus. It's just a thing that, right, can only happen when the game's open. Yep. Okay. That makes sense. So we can live with that. That's good. Right, so there are a few more little options I'd like to do. So I guess this is like March time, isn't it? Basically, like the editor side of things. We need a way to do like a new material and stuff like that. So I do have time to think about this. What? Yes. Okay. So I guess I'll just try and work this out off stream a little bit more. But at least we managed to plan it out to kind of really good detail. So it should just be executing and not too many surprises should pop up, which is good. Okay. So next stream will be on Tuesday at, well, when would it be? 2.5 hours ago, but on Tuesday and Thursday. And we'll be working on the texture cache this week. So for those 2 days, then next Sunday, we'll work on the renderer changes to load from textures instead of just hard-coded material values. And yeah, in the meantime, guys, there is a Discord if you can come out and chat off stream. I'll be uploading the code for those of you who support the channel over at Ko-Fi or on Twitch. Appreciate you guys. So yeah, put the code up in a second. And there's a YouTube channel. Please go and subscribe there. It's all free, right? It's YouTube. Subscribe there for free, and then we can hopefully stream on YouTube very soon. We've got 200 more people to join, and then we can do that. So please, if you could spread the word for folks to subscribe there, that would really help me in the future. And who's this lady? Right. Let's go to raid. There is a Jai guy who's definitely got the John Blow theme going on here. It's Valago. Trey Valago. He's got a very similar looking themes to John. Rightio. I'll see you all in the future stream, guys. Catch you later. Bye bye. Have a good social work week.